Welcome back everyone. So in this video we are going to introduce our next unit, which is all about this thing called exponential growth. Now we know all about linear growth, so we are going to use today to just compare what we know about linear growth to this new type of growth. And we're going to do that using tables and then equations and graphs as well. Alrighty, so here's the setup for our problem. We are looking at this bunny situation, and you can pause the video and read through it if you would like, but I'm just going to summarize it. So we have two friends that are going to start a bunny farm, or a bunny sanctuary, I guess you could say. And in their situation, I'm going to highlight our important information here. We start off with two rabbits, or two bunnies, and that every month that pair of babies, so that pair of bunnies is going to have two baby bunnies. We're also going to assume that not only do they continue to have babies, but every pair of bunnies afterward also produces two babies. So that's going to be a little bit confusing, but when we do this, we're going to do this carefully by drawing pictures. Alrighty? So I'm actually going to write that off to the side just so that to help you guys take notes. So I'm doing problem 5-1 here. Okay, so in our situation, whenever I'm taking notes, I'm not going to write down the entire paragraph because that's a lot of writing to do. But I just need to summarize the important things, right? Now, obviously, I can just highlight it here because I can just grab a screenshot of the textbook, but that doesn't help you when you're in class. So one thing that I'm going to write down is that we start with two bunnies. Right, and again, I'm just using little sentence fragments, not even complete sentences, little bullet points. If you feel the need to use complete sentences because it makes your notes, more readable and easier to understand later, then write complete sentences. And we also know that every pair has two babies each month. The other important thing that I would want to write down is what the actual question is asking me to do, because if I don't know what the question is asking, then I can't answer the question. And so we continue reading here. We read our task, and it says that we are going to determine how many rabbits we're going to have after 1 year. And we're going to do that again with drawings, table, and also just describing the growth and noticing the patterns. Okay, so the question, big question, I'll just put big Q here. How many bunnies will we have after 1 year or 12 months? What I also want to do in this scenario is actually compare this to something that would be more familiar to us. So I'm going to call this situation that we're curious about situation A, and I'm going to create a new situation for us B, and let's say that we start off with the same amount. Start with two bunnies, but in this case the bunnies don't reproduce. Let's just say maybe they're too old, but instead we just bring 5 new bunnies to the farm each month. So maybe this is like a bunny retirement home if you want to think of it like that. And so we add 5 bunnies each month. Okay, so I think with situation B, it's a lot simpler, so we'll just kind of save that one quickly. Let's just start with that one. So for B, I'm just going to make a table here, month and number of bunnies. Okay, so if today is month 0, right, we'll start with month 0, and then we have 2. So in 1 month, we know that we're just going to add in 5. So I'm going to I'm going to show that growth in my table. Let's make that a little smaller. Plus 5 there, and we're going to end up with 7. And then we'll go on to 12, and then 17, and so on and so forth. This is not too crazy. We actually know how to create the equation for this, so I actually don't need to follow this table all the way through to get to 12 months. We already know that if in any given month X, since I know the growth rate and the starting value, again our growth rate being plus 5 each month. And our starting value being 2, that our equation is just going to be 5x plus 2. But I'm going to write it this way just for now. It's going to look maybe a little awkward, but all right, as 2 plus 5x. There's a reason for that. It'll help me when I compare this to our other situation later. Alrighty, so then in situation A, I'm going to, again, do the same thing, set up a table. I'm going to give myself a little bit more room in this table, though, because I'm going to draw some pictures to kind of fill in the gaps. Okay, so again, we have 2 bunnies to start right here. I'm going to draw my picture just off to the side here. All right, pretend those are my bunnies. Okay, now we also know that in the following month, those 2 parents are going to have 2 babies, right? That one pair has 2 babies. That's what it says. Each pair has 2 babies. Alrighty, so I'm going to start off with my parents. So I'll start a row here for my parents. Those are the original 2 from the previous month. But our babies, well, they have 2 babies, so we have 2 more. And so altogether, we have now 4 bunnies. Right, just pause a second there to just make sure we understand that. Again, it says every pair of bunnies has 2 babies. It does not mean that this bunny has 2 and then this one has 2 more. That's not what that means. There was a little bit of confusion in that in class. Okay, oops, sorry about that. Okay, so now when we go to the next month, so sorry, you might think, okay, now it's just the pattern's just plus 2, or maybe you might notice another pattern. And that's great to make predictions. We definitely should be doing that. But we can't make a pattern based off just one instance. So we definitely need to continue this and just see if your pattern works or not. Alrighty, so let's do the same thing we did. We have our parents, 1, 2, 3, 4 now. I guess this is also not stated in the problem, but we are assuming that the bunnies are mature enough to have babies after just 1 month, right? Which I'm not a bunnyologist, so I'm not actually sure if that's true, but we're gonna go with it in this problem. Alrighty, once again, this pair, 2 babies, and this pair are also 2 babies. So we're gonna end up with 1, 2, 3, 4 babies for a total now of, well, 2, 4, 6, 8 bunnies. Okay, so if you thought your pattern was plus 2, well, we can see here that that's not quite right. Right? It goes from 2 to 4, it's plus 2. Right here, plus 2, but then from here to here, it's plus 4. So that's really, unfortunately, not quite going to be the case. Right? We might think now, well, maybe plus 2 doesn't work, but you might notice that, hey, maybe it's times 2, and then times 2. And that so far works, but just to confirm, let's just run it one more time, just to be safe. And so if we do that, then we would think that it's going to be 16. So let's at least keep that in mind. For the 3rd month, I have 1, 2, 3, 4, 5, 6, 7, 8. I'm not going to draw the ears. That's going to take me a little too long. But again, this pair has 2, 2, 2, 2. So I have 1, 2, 3, 4, 5, 6, 7, 8. And so yes, we will have 16 bunnies, and I think it makes sense then that our pattern is times 2. Let's kind of just try to think about why this makes sense, or why in this situation, why times 2 is a logical pattern. Notice that in this situation, every pair has 2 bunnies once again. So a pair is already 2 bunnies to begin with. And so if they have 2 babies, well, this basically ensures that the number of parents and the number of babies is always going to be the same for every month. So if you have this many, if you have 100 parents, then you're going to basically have 100 babies. And so when you add them together, they're just going to double because it's the same number. Alrighty, so that makes sense. And so if we wanted to figure out then how many bunnies after 12 months, we would just need to follow this pattern, times 2, times 2, times 2, all the way out to 12 months. Oops. To 12. I'll give you a second to do that on your own. Just pause the video here. Okay, you have done that. I assume. So if we follow this pattern, you should end up with 8,192 bunnies. I realize now that we did not do that for the other one. So if we just check this, we'll just plug in 12. We don't need to do this one, one at a time because we have the equation. But if I just plug in 12, we should end up with just 62 bunnies. Again, I'm just plugging in 12 for x. Okay, what I would like, so we can see already comparisons. In this situation, where this is times 2 times 2, times 2, we have 8,000 bunnies. And then when we just add 5 each time, we only have 62 bunnies. So clearly, exponential growth, which is what this is. Okay, so I kind of spoiled it already. So exponential growth, let's define that, is growth by constant multiplication. Multiplication, right? In this case, it's times 2 times 2 times 2. Again, I'll just write down linear growth over here just so we remind ourselves. But over here, linear growth, but we've talked about this plenty already, is growth by constant addition. Now again, we could also say constant subtraction if you wanted to, but again, subtraction is just addition by a negative number. So we'll just save our breath and say addition. One thing I do want to point out is this is why I don't like just saying linear growth is constant growth, because in a sense, both of these types of growth are constant. It's just what operation you use to grow is different. So again, linear growth, constant addition. Exponential is constant multiplication. Okay, I just wanted to pause there to double check something. Now, what we want to do now is create an equation for this. Can I create an equation to represent this scenario? In month X, how many bunnies am I going to have? Because we can see there's going to be a lot of bunnies at some point, right? But if I want, just like in the linear case, hey, in maybe 10 years, how many bunnies are they going to be? I want to answer the same question, or at least be able to answer the same question in the situation B, the exponential case. So how can I do that? And there's a reason I did these side by side. So let's just take a look here. Okay. So I'm going to work on the linear table over here. And this is the reason I wrote the equation as 2 plus 5x as opposed to 5x plus 2, excuse me. Okay, so let's check this out. I could think of every one of these as starting from my starting value. So here's what I mean. I started off at 2, and then I added 5 to get to 7. So I could just say 2 plus 5. Okay, whatever. I can still do the same thing here, same idea. I started off at 2, and then I added 5 twice. I did 5 plus 5. Now, I can do the same thing. 2 plus 5 plus 5 plus 5. Okay, but if I was asking you, hey, how do I do, say, 5 plus 5 plus 5, you probably wouldn't do, I'm guessing, at this point in your math career, you wouldn't actually do 5 plus 5 is 10, 10 plus 5 is 15. You would just say 5 times 3, I think. At least I hope that we would get there at some point. Because this is just 2 plus 5 3 times. That's exactly what multiplication is. Multiplication is a tool to just add things up faster. Similarly here, we started off with 2 and we added 5 twice. We started off with 2 and added 5 one time. Over here, we started off with 2 and then we added 5, 0 times. And so the pattern still works. And this is why the equation is 2 plus 5x, because we can see, hey, our growth rate is right there. That's how many, every jump that we took, that's how we grew. Our starting value doesn't change. Doesn't change. It's still just 2. That's where this comes from. Oops. And then let's see, I need another color here. So let's grab, I guess, green. This number right here, the number of times that you used your growth rate, is over here. That's the month, and that's X right here. So let's write that out. For this thing, the x, tells you how many times you grew, or grew. The red thing right here, our slope in this case, is, again, that's our slope. It's how you grow each time. And then of course our 2 here is our starting value, or our y-intercept. Right, this is our starting value. What's neat about the linear, from linear to exponential functions is that exponential functions are going to have all 3 of these pieces in their equation. And I hope that they look very, very similar, because I think they should. And that'll help us kind of remember its equation. Okay, so I go back over here. I'll zoom out. I'm going to start off with this one. Now, again, I started off with 2 in month 0. So I'm going to start off with 2. And then I multiplied it by, from here to here, I just took the original 2 and then multiplied it by 2. Now, this one's a little bit awkward because the growth rate and the starting value are the same. But I'm going to try to separate those for you. So bear with me here. Let me scooch that over a little bit. So that's going to equal 2 times 2. This one is, well, to get to 8, I started with the original 2, and then I made 2 jumps of times 2. So I went times 2 to get to 4, times 2 again to get to 8. 16, we start off with 2. We went once, twice, 3 times to get to 16. So I went times 2, 2, 2. Oops, like so. And now hopefully we can notice the pattern. And then of course the starting point we just did times 2. So once again, that starting 2, is our starting value right there. Oops. We can also see here, I can rewrite this as, well, in this case, I start off with the original 2, and then how many times did I use our multiplier, or that common jump of times 2 each time? Well, I did it 3 times. I can see it right here. 1, 2, 3. And so the way I could represent, hey, 2 times 2 times 2 is with exponents. Right? So over here, multiplication is just a way to do repeated addition faster, to write it faster. The equivalent, or the analog, or the analogy, I guess, for repeated multiplication is exponents, and that's why it's called exponential growth. Okay? So this equation will be 2 times 2, 3 times. This one right here is, we started off with the original 2, the original 2 bunnies, and then we doubled twice. Here we started off with 2 and we doubled once. And over here we started with 2 and we doubled 0 times. Now, depending on when you're watching this video and the way we structure our class, we have not talked about our rules of exponents. And so it seems weird that, like, what is this 2 to the 0 business? Just bear with me for right now if we haven't gotten there yet. Okay? I think this year, in what year is this? The 2021-2022 school year, we did not talk about exponent rules yet, which is maybe a mistake on my part, but we will talk about those later. And so I'll forward those videos to you. But this pattern seems to hold just like it did for the linear situation. So again, this front 2 is our starting value. This 2, again, I know it's a little bit confusing because the 2 happens, it's 2 different things. It's the y-intercept, or the starting value and the multiplier, or the growth rate. But this 2 right here, with the exponent on it, is our growth rate times 2. And the last bit here, our exponent, well, that's how many times we multiplied, how many times we used that growth rate. And so for us, our equation is going to be this. In this situation, it's going to be, I guess, y equals, I should have put y equals here, sorry. Y equals 2, again, our starting value, times 2 to the x. And that's always going to be your exponential equation. And we'll generalize this in a later video, but I just want to guess, this is really just a preview for this. So again, this first 2 right here that is our starting value. Value. This 2 in red with the exponent on it. Again, be careful for order of operations. This exponent only applies to this. It doesn't also apply to this. And so just be careful if we were to plug things in. So this is how you grow each time, but be careful. This does not tell us how much we add. It tells us how much you multiply by. And so we don't use slope anymore because slope is strictly for linear functions. We call this thing, well, since it tells us how we multiply, we call it the multiplier. So that's equivalent for the slope of an exponential function. You can think of it like that. And this thing, again, is how many times we use that multiplier. How many times you grow. Okay, so when we could double check this for our equation, I'm just going to do a quick little check here. Oops, sorry, that's not an E, that's a C. So I'm going to plug in x equals 12, and I should get to 8192. So again, I'll plug in y equals 2 times 2 to the 12th. Again, order of operations says do this first. So I have 2 times 2 to the 12th, and so double check me on this in your calculator. But this should be 4096. And so then when I double it, I get to 8192. Okay. Alrighty, I'm gonna pause the video here, or stop this video just for keeping it short, and so then I don't have to upload a giant video. But we will finish up the rest of this task in the next one. But we have done, again, most of the work here. Alrighty, next one, just a couple examples. So again, we know all about linear growth. That's adding the same number every time, like plus 5, and we know how to create their equations. We've done that right here. Now, exponential growth is a similar idea in that it just starts with some starting number and then it multiplies every time instead of adding. And hopefully you can see that their equations are actually very, very similar. And one way that we can think of it, that I've kind of been taught, and this may or may not help because it's been a little bit, it's definitely kind of out there in terms of reasoning. But if we think about how this equation connects, so let me just go over here. Oops. Y equals 2 times 2 to the x versus y equals 2 plus 5 times x is that if we think about the different pieces, so at first it's the adding just turns into now multiplying, and the multiplying turns now into exponents. So in a sense, they kind of got like upgraded because multiplying is just repeated addition. So that's why this one makes sense. And then exponents is just repeated multiplication, which is kind of why that one makes sense. Again, that's not super formal by any means, but it's just been a way that was explained to me and it made sense to me, so it might make sense to you. Anywho, I hope that helped, and I'll see you in the next video, hopefully.